Today we're going to look at some properties of limits and how to do limits from a table. So you'll need a calculator for later on today. Alright, so before we begin, let's take a look. We're going to have two limits. We have a limit for f of x and g of x. Now, f of x approaches L. So remember, we're approaching L. And g of x approaches M. And that's what it means to be a limit. These properties right here are just some simple properties that we can use. What's called the constant property, if you take the limit of a constant, you just get that number back. An example would be like this. If I take the limit as x approaches 3 of 6, that's just 6, no matter what. We have what's called the substitution property. Now this is what we're going to talk about in a couple of days. That's going to be actually tomorrow night's homework. Okay, that's going to talk about tomorrow. We have a scalar property, which means if you're multiplying a limit by some constant, you can just multiply your answer by that constant. You can add or subtract properties and limits. You can multiply and divide limits. And that's what those two are going to do. So let's take a look right here. We have two limits. We have f of x and g of x. As f of x, the limit as x approaches c of f of x is 5, and they tell us the limit as x approaches c of g of x is 7. And they want us to use this to help us with these properties right here. Now for the first one, if you notice, this is our scalar property. Basically what it says, I'm going to take 3, pull it to the outside, and I'm going to look at this as the limit as x approaches c of f of x. I can just factor that 3 out. And this becomes 3. Well, what's the limit as x approaches 3 of f of x? It's 5. So the answer is 3 times 5, which is 15. Now, I don't expect you to do this much work. It's pretty easy to do, as you're going to find out. So for like number 2, this is our subtraction property. We're subtracting. The limit as x approaches c of f of x minus g of x. Well, according to my rule, I can just subtract their answers. F of x was 5, g of x was 7. So 5 minus 7, we get negative 2. The same thing if we're dividing. As x approaches 3, what happens to the quantity f of x divided by g of x? Well, again, I can just divide it. F of x is 5, g of x is 7. So we're approaching 5. The limit is 5 over 7. Try number 5 here. Now we're multiplying. So the limit, if I'm multiplying, we can multiply their answers. F of x approaches 5. G of x approaches 7. And if you multiply them together, we get 35. Now 5 gets a little bit more tricky, so let's take a look at this one. So for 5, we're going to take 2 times f of x, add that to 3 times g of x. So very easy to do. Use my scalar, negative 2. F of x is approaching 5, plus there's my 3. G of x is approaching 7. And we get negative 10 plus 21, we get 11. So our limit here is 11. Now 6 is also another hard one. We have this x and this f of x as we're approaching c. Now x is a hard one. We're going to leave that here for now. X times, what does f of x approach? Whoops, missed it. There it is. f of x is approaching 5. But the problem is we're going to substitute in for the x in this case because it's not a function. So we're going to replace the x with c times 5, and we get 5c for our limit here. That's a slightly harder one. You may want to take a look at that one a couple more times if you need to. So let's turn this over, take a look at some examples from a graph. Very easy to do. These should look a little familiar. Okay, for the first one, it's as we approach 5, be careful, we got that little minus sign from the left. So, of f of 3, negative 3 times f of x times g of x. Copy down the negative 3. Well, from the left, let's look at f of x. From the left, we approach negative 5. Remember, we're coming in from the left. That's down here. Here's negative 5. We're approaching it from the left. We're approaching negative 1 times g of x. As we approach 5 from the left with g of x, we're approaching 3. And that's easy to do. We get 9. That's 3. That's our negative 1. Let's try 8. The limit as f of x approaches 5. Well, as we approach 5 on f of x, remember, we're coming in from the left. Remember, because there's no sign, we want the left to equal the right. So if I come in from the left, I'm approaching 1. If I come in from the right, we're approaching 1. So this becomes 1 plus g of x if we approach 5. From the left, we're approaching 2. From the right, we're approaching 2. So we are approaching 2 here. And what's 1 plus 2? 3. Very easy to do. All right, let's try number 9. Now we have a power here. That's very simple. Don't change anything. So we want to approach f of x at negative 2. Here's f of x. At negative 2, what are we approaching? They're both heading to the same place, which is negative 1. So this becomes negative 1. And use your power. So we get negative 1. Negative 1 cubed is negative 1 right there. Very easy to do these. Remember, that's a g of x. Let's try number 10. Now, number 10 is a special one. I will tell you this. This involves our constant rule. So let's rewrite this as the limit as x approaches negative 2 from the right of 3 times g of x plus, and I'm going to split this up. See, you can actually kind of distribute limits. So leave it like so, if you want to. Now, for this one, we get 3 times. Now, as we approach g of x, g of x, there it is. As we approach negative 2, it says from the right, we're approaching 4. So this is going to be 4, because remember, we're approaching from the right. Plus, this right here is our constant rule. It doesn't matter what we approach. The answer is always just going to be 2, because there's no variable there. It's just a constant. And we multiply this out, 12 plus 2 is 14, and there's our answer here. So, see if you can try numbers 11 and 12, and we'll go ahead and go over those tomorrow in class. And then go on to part 2, we're going to take a look at how we solve these using calculators. We can do a calculator problem. Okay? I'll see you soon.